So, hello everyone, I'm Divya P, and today I'll be presenting the A star or A search algorithm. So, A star is one of the most powerful and widely used algorithm. Like it is used for finding the shortest path between 2 points. So, generally it is used in artificial intelligence like games, robotics, and GPS navigation system. The beauty of A star lies in how it smartly combines two strategies, like Dikshitra's algorithm, which focuses on actual cost so far and greedy base for search and which focus on estimated cost to the goal. So like I mentioned here, the custom graph with the heuristic value. So in this graph, you can see that it consists of 7 nodes A to G, each with heuristic value that represent the estimated distance from the node to the goal G. So for example, the heuristic value A is 10, for B is, for example, A is 10, if B is 8, for C it's 6, and for G it's 0 since it's the goal. So each edge between the nodes adds a weight that represent like the actual cost of moving between them. So our goal is to find the optimal path from A to G using the A star algorithm. So a formula concept is there which is given as f of n is equal to g of n plus h of n. Here g of n is the actual cost from the start node to the current node and h of n is the heuristic estimate from the current node to the goal. So this algorithm picks the node with the lowest total cost f of n. So this balance G and H makes A star both optimal and efficient. So let's go step by step. We start from node A, like node A. With the total cost f of a is equal to 0 plus 10 is equal to 0. So from A we can go from B or C. The f value becomes for B, G is equal to 4, H is equal to 8, and F is equal to 12. And for C, it becomes G is equal to 3, H is equal to 6, F is equal to 9. So since C has smaller F value, we move to C. From C, we can go to F with a cost of 10. So F of F is equal to G of 3 plus 10 plus H of 5 is equal to 18. So like in short, I illustrated here in the PPT, but by doing the mathematical representation, we can calculate this A star search. So the principle behind the A star search is that the two types, open list and the closed list. So the open list for the nodes that need to be evaluated and the closed list is for the nodes that have already been evaluated. So it's continuously exploring until it reaches the goal node, always choosing the path with the lowest estimated cost. So when the heuristic used is admissible, meaning like it never overestimate the real distance. So A star is guaranteed to find the optimal path. So its key feature and the conclusion of the A star search is that it is complete, like meaning it will always find an optimal solution if no one exists. It is optimal, like it will find the least cost spot when using an admissible heuristic, and it is so efficient because it uses heuristic to avoid exploring unnecessary part. So generally its a real world application is that it is used in the GPS navigation systems like Google Maps to find the fastest route between the locations, and in game AI particularly it is used for the character movement and enemy tracking, and in robotics it is used for autonomous path planning, and in network routing also it is used to automate some data packet transmission. So its significance is that it's mostly guarantees the most efficient and optimal route when the heuristic is properly designed. So A star is a most powerful smart combination between the Dikshitra's algorithm and the greedy search. It actually uses both actual and estimated cost to find the best efficiently. So thank you for listening. I hope this helped you to understand how A star search works and why it's so powerful in real world problem solving. Thank you.